My name is Dr. Alfred Nsekiwa. I'm a senior lecturer at the School of Health Systems and Public Health at the University of Pretoria. Welcome to this session on summary statistics for numerical data. In this session, we'll talk about measures of average and measures of variation for numerical or quantitative data. In the previous session, we said that numerical data can either be measured, that is continuous variable, or count, that is discrete variable. Continuous variable takes any value in an interval. For example, weight can be any value between 40 to 100 kg for a given sample of people. Discrete variable only takes specific distinct values. For example, number of hospital admissions last year could be 0, 1, 2, 3, and so on. Measures of average are also called measures of central tendency. They help you to see what is the typical value or where the middle values lie. Remember the previous example where you have data on ages of 1,000 patients and you have raw data on a list of 1,000 ages in years. You can't make sense of this data. So you want to know the average age of the sample. You want to use one value to summarize the ages, so to speak. You can calculate the mean, the median, or the mode. We will talk about each one separately and see which one to use for which situation. To calculate the arithmetic mean, you add or sum all the values and divide by the number of values. For median, arrange the data in increasing order and pick the value in the middle. If you have an even number of values, you add the two numbers in the middle and divide by 2. The mode is the most common value, the value that appears most frequently. See examples in the slide. There are advantages and disadvantages of the mean and the median. The first thing to do when analyzing a numerical variable is to know the distribution of the data. You can do this by constructing a histogram and then look at the symmetry of the data. If data are symmetrical, use the mean as a measure of central tendency because it uses all the values in the dataset in its calculation and therefore has better statistical properties. If data contain outliers or extreme values, which means the data is skewed, the mean is influenced or swayed by the outlying values and therefore is not suitable as a measure of central tendency. Therefore, for skewed data, use the median as the measure of central tendency. The other advantages and disadvantages are in the slide. I use the terms measure of central tendency and measures of average interchangeably as they mean the same thing. That is mean, median, mode. However, mode is not frequently used. Now let's go back to that example of having collected a sample of 1,000 ages in years. Not only are you interested in the average or measure of central tendency or what is in the middle, as we have covered in the previous slide, you also want to know how spread or how varied or how scattered the data are. We have a number of measures we can use to quantify variation or spread of the data. The most important one is the standard deviation. But when data are skewed, you should use the range, percentiles, or interquartile range. We will explain this in detail in the following slides. Let's start with the range, which is the simplest. You just arrange your data in increasing order and you pick the smallest, which is minimum, and the largest, which is maximum. Then the range is simply from minimum to maximum. See example in the slide. When you read some statistics textbooks, you may see that they say range is equals to maximum minus minimum. In this module, we want to say the range is from minimum to maximum, as this gives us more meaning. Now, we move to percentiles, which help us to know the values of a dataset in relation to their ranks or position. First, rank your values in increasing order. By definition, a pth percentile is a value such that p% of the values are below it. Let's make it simple. A 25th percentile is such that 25% of the values are below it. If we have the ages of participants, a 25th percentile is an age such that a quarter of the participants are aged below it. As you may have guessed, the 50th percentile is the median. The 25th percentile is known as the first quartile, and the 75th percentile is known as the third quartile, as these values divide your data into quarters. See example in the slide for the actual calculation of percentiles and quartiles. The range from the first quartile to the third quartile is known as the interquartile range, IQR. This is so special as the IQR includes the middle 50% of the observations and also excludes extreme values. It leaves the first 25% to the left and the last 25% to the right. Because it is so special, there is a graph or chart that displays the interquartile range, and it is known as the box and whisker plot. We will cover graphics in the next session. Now we move to the most important measure of variation known as the standard deviation, or in short SD. It is very easy to calculate. You will simply have to follow the steps in the slide. Now, let's go through the steps. Number one, you find the mean. In other words, you calculate the average or the arithmetic mean by adding all the values and dividing by n, the sample size of the number of values. Number two, you subtract the mean from each of the values. So you go to the first value, you subtract the mean, you get the answer. You get to the second value, subtract the mean, you get the answer, and so on. Third step is to square each of those differences that you got in the previous step. So where you were subtracting the value minus the mean, you now square the difference that you get. So even negative differences will become positive. Number four, you add up the squared deviations. What you see there is called a sum, or a sigma, capital sigma in Greek. So sum of xi minus x bar squared is simply the sum of the squares of each deviation from the mean. If you add that and you get the sum, step number 5, you divide the sum by n minus 1, which is the sample size minus 1. What you get is the variance. In other words, variance is equal to sum of xi minus x bar squared, all divided by n minus 1. Step number 6 is to take the square root to get the standard deviation. So the standard deviation is equal to the square root of what you get in step number 5. In the next slide, we use an example to calculate the standard deviation so you can understand this step. See the example in the slide. Assume we have a small sample with values 10, 12, 20 indicated on the left column of the table. You first calculate the mean, which means you add 10 plus 12 plus 20, you get 42, and you divide by 3, and you get an answer of 14. So the sample mean is 14. You then subtract the mean from each value, and say 10 minus 14, you get minus 4, 12 minus 14, you get minus 2, 20 minus 14, you get 6, as shown in the second column. Next, you square each of these deviations to say minus 4 squared, you get 16, next you get 4, next you get 36, as shown in the third column of the table. Then the next thing is to sum all these squares. In other words, you are summing what is, or you are adding up what is on the third column, which is 16 plus 4 plus 36, you get a total of 56, which you will divide by n minus 1. Now in this case, n is 3 because we have 3 values. You divide 56 by 2 and you get 28. That answer that you get, 28, is known as the variance. You then find the square root of the variance, and the answer is the standard deviation. The square root of 28 is 5.29, so our standard deviation is 5.29. But what does the standard deviation actually mean? The following slides addresses this question. Well, for status, we know that a bigger standard deviation means bigger variation. In other words, your data will be very much spread or scattered from each other if they have a bigger standard. Standard deviation can easily be interpreted when data are symmetrical, which we also call normally distributed data. Standard deviation should only be calculated when data are symmetrical because it uses the mean in its calculation, as you have seen in the previous slides showing the calculation of standard deviation. We are trying to understand how to interpret the standard deviation. The standard deviation is such that 95% of the data are within 2 standard deviations of the mean. Now, what does that mean? Remember the example of 1000 ages in years. Now, suppose the data are symmetrically distributed. Suppose I calculate the mean and I get 50 years, and I calculate standard deviation and I get 5 years. Then it means 95% of the ages in my data set lie between 50 minus 2 times 5, which is 40 years, and 50 plus 2 times 5 years, which is 60 years. So the standard deviation has helped me to know the variation in my data. That is, 95% of the people in my sample are aged between 40 and 60 years. Now let's see what happens if you use the standard deviation in a skewed distribution. That is where data has outliers. The example in the slide shows that you end up concluding that 95% of the blood loss data are between minus 33.8 mils to 122.2 mils. But how can you have negative blood loss? Impossible. This can only point to the fact that the data are not symmetrically distributed. Actually, the wonderful thing about this is that if you have the mean and standard deviation of a dataset, you are able to know whether the data was symmetrically distributed or skewed. Simply calculate mean minus 2 times standard deviation. If value is negative and your quantity only takes positive value, then you know that your data are skewed. Otherwise, when mean minus 2 standard deviation is positive, then data can be assumed symmetrical or normally distributed. Remember, you only use standard deviation when data are symmetrically distributed. For skewed data, you use the interquartile range as a measure of variation. And remember, standard deviation and interquartile range are measures of variation. We are not talking about measures of central tendency that we have covered already. In summary, when you have a numerical variable, first do a histogram and see the distribution. If symmetrical, use the mean as a measure of central tendency and standard deviation as a measure of variation. In other words, you do the mean and standard deviation. If you find that your data is skewed, you use the median as a measure of central tendency and interquartile range as a measure of variation. In other words, you calculate the median and interquartile range. Mean and median are measures of central tendency. SD and IQR are measures of variation or spread of the data. This is my email address if you have any questions.